Good morning, this is your stats sensei, Mr. Spensei, and we're looking at a 1999 question 4, and it covers the inverse norm and the binomial. In my opinion, this is a fairly challenging problem. So a company is considering implementing one of two quality control plans for monitoring the weights of automobile batteries that it manufactures. If the manufacturing process is working properly, the battery weights are approximately normally distributed. That's important. They're telling us it's normal, which means we're probably going to be doing work with the normal, with a specified mean and standard deviation. That kind of stinks. They didn't tell us what it is. Quality control plan A calls for rejecting a battery as defective if it falls more than 2 standard deviations below the mean. Okay, so in other words, if it's more than 2 z-scores below the mean. And I'm going to read B later. What proportion of the batteries will be rejected by plan A? Well, let's draw a picture. So they didn't tell us, they did not give us the actual mean, but we know z-scores. So we have 0, 1, 2, and 3 up there, -1, -2, -3. And I said, you know what, if you fall more than 2 standard deviations below, we're going to reject. So we want the probability. And remember, another term for standard deviation is, when you're talking about the normal, is the z-score. So the probability that z is less than or equal to -2. Well, there's not a whole lot of work we could do in this case. So we're going to go to a second vars, normal CDF. Our lower bound, -infinity. Our upper bound, based on our shading, is -2, and a mean of zeros, because all z-scores have means of 0 and standard deviation of 1. And we end up getting 2.28. So equals 0.0227. Now, some people would use the empirical rule. If you use the empirical rule and said plus or minus 2, you're going to end up with 0.95, 1 minus that, and divide by 2, and you get 0.025. So the empirical rule would also work, okay? All right, part B. What is the probability that at least one of 2 randomly selected batteries, we have a specific number of trials. As soon as I see specific number of trials, I know I'm working with a binomial. Trials equals 2. Probability will be rejected by plan A. Oh, that means I have to use this probability. So the probability equals 0.02275. All right. And remember, binomial will have a number line of, well, 0, 1, 2, and we're looking with the probability that at least 1. So we're looking for this. And we want the probability that x is greater than or equal to 1, where x is the number of batteries rejected. And there's a couple ways to show your work. So we can actually do this as the sum of the PDFs, which in this case, we're going to be showing our work as the probability of 1 plus the probability of 2. So 2 choose 1 times 0.02275 to the first power times 1 minus 0.02275. 2 minus 1 is 1, plus 2 choose 2, 0.0 0.02275 squared times 1 minus 0.02275 to the 0 power. All right. And so this is a binomial CDF, 1 minus the binom CDF trials equals 2, P equals 0.02275. And then our X value, we always subtract out the highest one we don't want, which is X equals 0. So 1 minus second vars, binomial, CDF, trials is 2, probability 0.02275. The value we don't want is 0. And we end up getting 0.0449. All right. So far, so good. Then we're going to move on to part C, and it says what proportion of the batteries will be rejected by plan B. So let's look at plan B. Quality control plan B calls for rejecting a battery as defective if its weight falls more than 1.5 interquartile ranges below the lower quartile of the specified population. So we're talking about quartiles and interquartiles, and we're saying, hey, you know what, we're going to reject if X is less than Q1 minus 1.5 IQR, but IQR equals Q3 minus Q1. So the problem with that is I need to know what those interquartile range values are. So I'm going to have to go back and calculate my interquartile ranges, and I don't have a whole lot of information. But what I do know is this is my 75th percentile, and this is my 25th percentile. So let's go ahead and calculate Q3. And Q3 I'm going to show like this. I want this value, this is z-score, for 0.75. So second vars, inverse norm, 0.75, mean is 0, standard deviation of 1, gives me a z-score of 0.6744. So Q3 has a z-score of, so IQR equals 0.6744. That's that one. Then I need the 25th. So second vars, inverse norm, 0.25. Redrawing it for the 25th. And this is 0. This area right here is 0.25, and I end up getting negative 0.6744. All right, for that z-score. So now that I have that z-score, I can write it here minus a negative 0.6744. So let's get that value. Enter minus that value. And I end up getting an IQR of 1.34, and we'll just call it 9. So my IQR equals 1.3489. And I'm going to plug back in here. Well, we already said that this is IQ1, and I'll go ahead and back and label that. That's Q3. This is Q1, is negative 0.6744. minus 1.5 times the 1.3489. So enter minus 1.5 times that value. Oops, there we go. Got too clever. So negative point, let's clear this. So negative 0.6744 minus 1.5 times my IQR of 1.3489 equals, that's not right. Try again. Negative 0.6744 minus 1.5 times 1.3489. And we end up getting negative 2.6975. So if X is less than negative 2.6977, negative 2.69775. So what I'm looking for is the probability that X and actually Z is less than negative 2.69775. So this is normal. Our mean, 0. All right. So let's find this probability. And we have 0, 1, 2, 3 standard deviations, 1, 2, 3 standard deviations, negative 1, negative 2, negative 3. And we're looking for this value right here at negative 2.697. So this is going to be a norm CDF, second bars, norm CDF, lower bounds negative infinity, upper bound negative 2.69775, mean is 0, standard deviation of 1. And we end up getting 0.0034. And that's my answer. And our standard deviation is 1, because all z scores have a mean of 0 and a standard deviation of 1 if we're working with a normal distribution. This one was a fairly challenging problem. Generally speaking, if you showed your IQR calculations and got this, they gave you full credit. All right. Sure appreciate you watching, and I hope this helped. See you on the next one.